Welcome, Mark. Stage is yours, man.
Oh, hey, thank you very much. Okay, let me go ahead and share my prezo again. Share entire screen. Hopefully this will work. There it is. Okay, great. I love it when things work. Speaking of which, today, boy, this is just going to be a fast-paced presentation because I'm told I only have 3 hours. That's right, Bruno, right? Okay, just kidding. So I took a far-ranging talk and I've scaled it down, but I feel like the essential elements. So if I miss something, if I don't expand on something as much as you might like, by all means, please let me know. I probably agree, and I'd be happy to talk about additional things offline. But we're going to talk today about production best practices, or how to go from dev to delivered and stay there, kind of my Lord of the Rings-esque title there. My name is Mark Heckler. I'm a principal cloud advocate of Java and JVM languages with Microsoft. I will have questions and answer time, I hope at the end, at least a few minutes. If you can't get your question answered within that time, or if you think of something later after the fact, which is what I usually do, please do reach out to me. I'm on all the socials as far as and most of them center around MKHack. So on X, I'm MKHack. On Mastodon, I'm MKHack at mastodon.cloud. I'm on Blue Sky under MKHack. The only exception is Mark. But other than that, I'm there. If you must reach out to me by email, obviously I'm on email, but you'll get a fast response typically on the socials. So with that, let me close out this little or hide this little message so it doesn't take over the screen there. And then we're off and running. A bit about me. I am an architect and developer by background. I am an advocate. That just means that I like to combine, or I get to combine, two of my favorite things in the world, coding and talking about it. I'm an author. If you're interested in the book, the latest book I've written, it has an X, Twitter, whatever handle as well. Follow it there. I'm a Java champion, an AI Jedi, and a licensed instrument-rated pilot. That last one, by the way, is the US FAA issued. The AI Jedi role, I still haven't received my certificate for. I don't know who I need to reach out to about that, but I'm sure it's in the mail, right? So a quick overview. We have a lot to cover in roughly 30 minutes together. We'll start by examining application best practices, focusing primarily on Spring Boot Java applications, but most of these principles do apply more broadly. It's just that many of them are specific to Spring Boot and Java. That's where I live most of my time, and that's where what I'll use for my examples. Then we'll move to infrastructure as code with a few different options you might choose to use. And then we'll talk about CI/CD, continuous integration, continuous delivery pipelines. I use GitHub Actions as a great example. Obviously, most of us park our code out on GitHub, either private or public repositories, and GitHub Actions. GitHub is a platform, right? So you might as well make full use of it since you have access to it. It's a great example. It shows some really great capabilities that are of great utility for all of us, right? We'll talk about monitoring and observability. And finally, we'll discuss some patching and security practices as well. So let's start with the application best practices. We need configuration of the app, of course, version control, build tracking, etc. And then externalize that configuration so it's versionable, it's versioned and refreshable. So that you can have better capabilities when you do cloud deployments in terms of refreshing different things live. You also can externalize that so that if you have any issues, you don't have to tear everything down and redeploy. You just basically update a configuration and refresh that as well. Actuator is the foundation upon which a lot of things are built, really. Even of that build information that I mentioned, using something like Get Commit ID Maven plugin or a similar plugin for Gradle, so that when you have your application deployed, you can point with that application information back to the build, the very code that it was used to build that particular release of that application. Actuator allows you to secure and only expose the specific information you want with the scope that you want. So you need to, there's a lot of great information, useful information that Actuator can expose, most of which you don't want to be exposed to the world in general, but is very useful for developers and operations types folks to get in and isolate and identify and resolve potential issues or troubleshoot things as need be. There are 3 pillars of observability, say that 3 times fast. 3 pillars of observability, logging, metrics, and traces. And those are also actually handled by Actuator and various extensions, additional libraries, and or configuration settings. Actuator provides dependency management and auto configuration for micrometer, which is a facade supporting a wide variety of monitoring systems. You have things like micrometer metrics, micrometer tracing, and actuator provides the foundation upon which all of that builds. And then, of course, in your application, you need error handling and resilience. Error handling because you need to properly address things that, again, can go wrong and often, well, hopefully not often, but occasionally do. And then you need to have a very resilient app, build in things like circuit breakers or retry and retries with back off. Typically, a clean degradation is usually better than an abrupt failure, depends on your circumstances, but of course, that gives you flexibility, and it's always good to have options. So containerization is a crucial aspect of modern deployments, right? So we start with base images. We build a container around that, or container image, I should say, around that. And then we look at ways to isolate our runtime versus build dependencies. We'll talk a little bit about multi-stage Docker files and when they come into play. And then we'll discuss some image security considerations as well. And I know I'm going kind of quickly on this. I don't want to gloss over anything again, but what I want to do is start a conversation about these things, cover the high points, and drill in a little bit into certain areas, but certainly set the stage for us to have this ongoing conversation as we go. But I wanted to give the most information, maximize our coverage here. So as developers, we typically start when we approach containerization, because containerization is typically apps. So how do we get started with that? As a new developer, I guess, to this part of the life cycle, we'll typically start with a Docker file. And we'll go to the Docker documentation, we'll read up, we'll see the sample Docker files, we'll grab one of those. We'll use a full-size operating system. We'll drop Java and our app in there. We'll expose whatever ports we need to, and we'll define what the initialization application, the command to run upon initialization for a container based on that image is. And when it comes to containerization, I'm probably repeating something that most people know, but there are a few, right? Everybody's new to something at any given point in time. But when you talk about containerization, you create an image, and from that image, numerous different containers can be created that are identical, right? So your image in many ways is your template from which your containers are built. So this works. And if you're kind of doing a proof of concept, pulling in that full-size OS, Java, your app, boom, you're off and running, and that's enough. But if you're doing this for very long, if you're working for a big company, if you're taking things from proof of concept to actual production, most of the time you look for ways to make things better, make things leaner. I'm going to say something that isn't 100% correlation, but it is a high level of correlation. Leaner is better. Smaller container image size typically parallels a tighter and a faster startup. It's faster to build. It's faster to deploy the containers from those images. Requires less storage, less memory, et cetera. That is a very broad brush approach to that. But you see a lot of correlation there. It's not 100%, but it's a high degree of correlation. The smaller the image, typically the better off you are. And again, very generally speaking. But what we want to do, and what we typically do, is evolve from a smaller base image in Java JDK input, right? And distroless offers the leanest base image. Now, distroless is like serverless. There's no server, there's no distro. Kidding. Distroless doesn't mean that there's no Linux distribution under there. Typically, what it means is you've pulled out every bit of non-essential stuff that you don't need to run your Java application. It is as close to 100% fit for purpose underlying OS as you can get. And I'm using an example here for our JDK 21 distroless base image. I'm pulling that from the Microsoft Container Registry. And the rest of it looks very similar, right? We're copying our jar, our pre-built jar that we've already created, typically on our local file system, to our container image. We're exposing a port. In this case, we don't have the Java command there because it's baked into our distroless build. But everything else is very much the same. And that makes a smaller image. Now, then we look at things like containerization or multi-stage containers, container images, builds. So multi-stage builds allow you to use a full featured base image for the first stage to build your app, jar or native binary, although in this case, typically, I'm going to show you just 100% jar files. And then we use a lean base image for that second stage, with or without the JDK as JVM versus native. But again, this is more applicable in this case, and 100% in my example here, to a JVM build. Because that way we can have the full OS, we can have our build tools like Gradle and Maven, we can do everything else that we want to do, need to do. We can pull in security or scanning tools, and we can build our jar file. And then the only thing we extract from that larger container image is the jar. That's it. And then we put that in as lean an image as we can down below. We create that, and that resultant image is much smaller, much tighter. It has a reduced attack surface because, again, there are no extra threads to pull, figuratively speaking. I'm not talking about CPU threads. But all superfluous utilities, config files, everything else that you don't need to run that app is absent, and you can't compromise what isn't there. There is more to consider about security, but we'll talk about that more in the next few slides. So everything that I've talked about so far is kind of the way that most people get started in terms of building container images for their applications. If you're a Spring Boot developer, you can actually use the Maven plugin or the Gradle plugin and do something like Maven W Spring Boot build image or Gradle W boot build image. And that kicks off a lot of built-in capabilities that you can use and put to good use for you. So this uses cloud native build packs. And there are build packs available for a lot of different languages, but of course, all we care about here is Java right now, and Spring Boot Java apps in particular, for the moment. So what that does is it uses a cloud native build pack to instruct it how to create that image. It pulls in a very lean base image, and then it also has certain pre-configuration settings. So it will has a predefined set of layers from the least changed things to the most changed things, the most changed being, of course, your application code, potentially. And those layers work pretty well. The predefined settings work pretty well in the cloud native build packs. So just by running this, it will create an output container image, an OCI container image. So the Open Container Initiative, we typically just shorthand call them Docker images, but it's an OCI compliant image. Can run anywhere you have a container engine. So that works really well. I would advise you, if you do this, to start with the defaults and only tweak if you need be, because you may want to tweak the layers.idx. You may want to change the layer definitions. Probably not, but you can. If you have a particular JDK that's supported by someone that your company contracts with for that support, if you have just a recommendation or a group guidance or whatever to use a particular JDK, you can swap that out. But again, you start from the defaults and build out from there, and that works very, very well as well. Now, let's talk a little bit about infrastructure as code, because so far we've talked about building that application and that container around that application, or container image that will create those containers that contain that application. But we need to obviously have a place to deploy that as well, and to build out our supporting services. So assuming we're going to deploy that to Azure, we'll need something like an Azure Container Apps environment, an Azure Container Apps app instance, the construct into which you deploy that app, that container. And then we'll need things, any supporting services like database services or messaging platforms or anything like that. So we need some way to do that in a repeatable fashion. And infrastructure as code gives us consistency. We can version control our infrastructure. We can, it has repeatability because you can literally pull the same scripts and run those and have the exact same outputs every time. You do have options for doing this. I mentioned a lot of times the ARM, the Azure Resource Manager, and ARM supports things like ARM templates, or you have ARM templates and you have Bicep, both of which are used with the Azure CLI, the command line interface, which is great. You also have other options, third-party options like Terraform, OpenTofu, Pulumi, other great options as well. We'll discuss those as we go along. State management strategies include how to handle different environments like dev, staging, production, etc. Different deployment targets may require different supporting services when you're going from dev to prod, for instance. You may have different databases underlying that or whatnot in different deployment scenarios and other things like that. So the basic high-level principles for infrastructure as code, you want to store your infrastructure as code files in version control systems, so you have the entire history of your infrastructure. So you can track changes, you can debug issues, you can revert to previously known good versions if you have any issues. Pardon me. Infrastructure as code ensures that infrastructure configurations are consistent across different environments because you represent the entire desired state of your environments via code. And by doing so, teams avoid errors due to manual configuration. It also enforces uniformity. Everything is 100% consistent when you pull from the same, drink from the same well, if you will. IAC acts as documentation, so you can kind of get that background and you can understand how things are being created and what's being created. It provides automated testing and validation because any changes go through full pull requests. You can have code reviews, static analysis, and transformations before you deploy it, even for the first time. So that elevates the quality of your infrastructure as code. And then finally, there's idempotency, which means that you can execute this repeatedly and produce the exact same result. So just a few examples here really quickly. We have our infrastructure as code. I'm using in this example ARM templates. ARM templates, as I mentioned, use the Azure CLI, which is up to date with each release of each platform target, which is pretty awesome. So if a new version of Azure Container Apps rolls out or AKS, you know that AZ CLI is going to be up to date and you're going to be off to the races as soon as the new features, the new APIs drop. Boom, you're completely up to date. ARM templates use JSON, which is ironically enough somewhat space consuming. I've collapsed a lot of these sections here because it just goes on and on and on. And space consuming, but it is when you compare it to something like Bicep. Bicep is much tighter. It's much neater. It's easier to read, in my opinion. Your mileage may vary, but it's more declarative. It is still JSON-esque, but it's much more declarative in my mind and not quite as space consuming. So taking it from there, we go to something like Terraform. And Terraform, I'm using Terraform as an example, but there are many other similar offerings throughout the industry that kind of parallel this type of implementation. Again, you have to choose a few things to show, and this is just what I chose here. Terraform uses a fully declarative syntax, again, and the Terraform utilities to execute on these, which all of that's pretty easy to work with, and the format is nice and compact, really. One big downside to using a third-party option like this, like Terraform, OpenTofu, Pulumi, and pretty much, is that with each API, case, let's say the Azure Container Apps API, but it could be like the Azure Cosmos DB API. But with each update for any platform offering, whether it's a destination, a service, whatever, there's a delay between the releases of the new platform API and its full support in that external, that third-party infrastructure as code toolchain and its templates. It just takes a little while for them to implement it, test, and deploy it so that the rest of us, the entire community, can use it, which is good. You don't want them to release stuff that isn't tested, right? That's a bad thing. But there is a delay. There is a necessary lag there. So that's a bit of a downside. Again, that's balanced against everything else. A lot of times people, and I've done the same thing over the years, look at a third-party option and say, well, that gives me a lot more independence because I don't want to be tied in, locked in, if you will. Not true, as I just mentioned, but I'll take that a little bit further. Because while Terraform in this example is independent of Azure, the actual resources and resource definition and syntax varies between, let's say, Azure and another cloud provider. If you notice, you have Azure RM, which stands for Azure Resource Manager, Container App Environment, and you have certain fields or variables that apply to that. You have the Azure RM Container App. And then you have other Azure Resource Manager type of sections that apply. And those don't apply to other cloud providers, for instance. So even with a third-party option for infrastructure as code, you're still very much cloud specific. So I don't see that as a huge advantage over something like the ARM templates or Bicep, but it is something to consider. You have that delay. You're still somewhat tied in, but of course your tools knowledge does apply across platform as well. So again, whatever you use, just use something to get that infrastructure as code versus having to manually configure and introduce variations and potential errors along the way. So, pardon me. So with each, once you have your infrastructure as code defined, you've got the ability to build out that infrastructure. You have the ability to build your app, test your app, containerize your app. Now, how do you get it to production, to those targets? So you have something like a CI/CD pipeline. GitHub Actions is a great example of that. And with GitHub Actions, you have the ability to define workflows and to create resources to build your app, test your app, deploy your app, even use things like blue-green deployments so you can make sure that you do an orderly cutover in production based on different triggers that you define, different branch PRs or commits. You kick off different workflows. Secrets are managed using GitHub or Azure Key Vault or other supported external secure mechanism. Unauthorized users never get to peep your keys, which is the important part. You have these tools interacting with each other securely, and you greatly reduce or eliminate any chance of secret leakage, which is super important. We don't want even the smallest secret to escape in the smallest scope, because that's a good way to become a headline, and no one wants to become a headline, not for those reasons. So just an example, your mileage may vary, but to use GitHub Actions, you have to, within some project, define a .github/workflows directory and populate that with various applicable workflows defined in your favorite format and mine and Bruno's YAML. Anyway, once you've created these using the applicable component actions like checkout code, setup Java, etc., you define the triggers that cause each one to run. And as you can see in this example, we have a small number of workflows that cover a lot of ground and that are triggered by a number of different things and at varying frequencies. For instance, the build workflow runs on every pull request and every push to main. The deploy to dev environment runs on push to main. The deploy to production workflow runs manually or on a particular release level. And then you have a security scan, which actually should be run on a scheduled basis, but also allow for you to execute that on demand at any time you feel like you need to do that. So in my example here, I only have 4, but they cover quite a lot of ground, and you're certainly not limited to what workflows you define. This is an example of secrets being handled within GitHub itself or by GitHub. You define the secrets your workflows require, provide the values, and use those variables in your workflows. Only in the appropriate workflows, of course. You don't want to expose all variables to all workflows. It's just not needed. And again, you don't want to add to your exposure. Secrets can also be managed by external secure mechanisms, like I mentioned, such as Azure Key Vault. This allows you to centralize key storage and administration in one place, Azure, eliminate redundancy, potential mistakes, and reduce your attack surfaces. Again, unauthorized users never get a hold of your keys. So some examples of my actions as I have here, and these are just small excerpts of some actions. They're actually much larger and can be very, very large depending on what you want or need to do. We have a build and test workflow, a deploy to development, and a deploy to prod workflow. And by the way, those two deploy to workflows call a common reusable deployment workflow that actually, based on flag set, will deploy to production or deploy to development. So you can reduce the code reuse or increase reuse, but you reduce the duplication of code, which of course is always a good thing as well. So you keep consistency and you don't let things potentially get out of sync inadvertently. So for that build and test workflow, you have an app build and a container image build. Of course, again, we do it all, right? During each workflow, it should all be tested in every way that's meaningful to maintaining quality and security throughout. So for instance, in the app dependencies scan or part of the workflow, what I do is I'm employing plugin to check the workflow, the application dependencies, excuse me, and Trivy to scan the container image built by the build and test workflow. Later, we'll explore the code quality checks and some ways to do that as well. But this just gives you an idea that we want to bake in security at every level throughout that pipeline, right? Just some high-level best practices for GitHub Actions workflows. Always use the exact versions for the actions you use, something like action/checkout at v4 instead of the action/checkout at main. You want to use a specific version number and then cut over within that workflow when it makes sense for you to do so, when you can test that and do that properly. Only use secrets in the jobs that actually need them. That probably should go without saying, but again, it's a good habit because we all get busy and we sometimes overlook things and we just dump things in that maybe we don't need. That's not a good practice. Add timeout minutes parameters to jobs to prevent workflows from running indefinitely. That's always a good practice, so you don't have an out of control workflow that just keeps running for no good reason. Add the concurrency parameter to cancel in-progress workflows when new ones are triggered. This also makes perfect sense. So you can stop something that really doesn't need to happen when you kick off another workflow. Create reusable workflows. And I showed you a very small example of that, but you should extract common functionality into reusable workflows to avoid duplication. Add thorough testing in the build workflow to catch issues early, and implement caching for dependencies to speed up those workflows. You should also finally configure notifications for workflow failures to appropriate channels, because you want to know ASAP when a build doesn't complete successfully, when a workflow doesn't complete. All of these capabilities, the monitoring capabilities, should be created when creating and deploying the applications or systems infrastructure. Bolting on these things after the fact is an anti-pattern, just the same as bolting security on after the fact is an anti-pattern. It doesn't help you. In fact, it hurts you in the long run. Short run, essential for applications. And Azure Monitor and application customs in it to define monitor business and app specific details that are important to you within this context, and defining a lot of logs for each. Now, here are some screens from a typical Azure. I guess I'm off.
All right. So, Mark,
Oh, no.
It seems like we're having some issues with the internet connection on your end. And we are also at time. So,
Yeah, can you?
Is there any message you'd like to wrap up with?
Can you hear me now?
Yeah.
Okay. Well, yeah, I guess let me see if I can flip through this. Yeah, key takeaways. Those are the key takeaways. So just automate everything, monitor what matters, secure everything, plan for failures, and improve constantly, continuously. And that's it. I would just point folks to the resources there at aka.ms/JavaLearn. We have a few out there. We're adding to those over time. So check them out, free resources. And thanks for coming.
All right. Thanks, Mark. Just but hang over there for a little while. I'd
Sure.
like to welcome on stage Yikang Zhang and Rich from IBM.
Hello.
Hello.
Hey, folks. How are you?
Good.
Good, good. Nice
So,
to meet you all.
You guys are going to talk about performance, and I have a comment here, Mark. I think if we want performance, we cannot have security. It slows things down. Is that correct?
Well, I mean, there has to be a balance, because if you have no security, then you have no performance, because you're constantly being hit with DDoS and everything else. So, I mean, it's a balance, right? You have to have both.
All about balance, which is interesting because Rich and Chang will exactly talk about balance. You know, they're going to show different options, and for each option, what are the pros and cons, so that developers can find a sweet spot to meet their needs based on what they have as goals. So, Mark, thank you so much for your presentation, and have a wonderful day.
Thanks. Good to be here.
All right, so Rich and John, so you're going to talk about instant on, crack, and native image. I mean, yes. I know about crack. I know about native image. Can you give me like a 30-second pitch for instant on?
Instant on is essentially what crack does. So the concept is to close down and restart processes. So it takes a snapshot of the image as it's already started, so that eventually what happens when you actually start that image, it starts really, really quick. So the concept is similar to crack, but it's just a little different methodology.
Okay. And all the security remains there.
Yes. And we'll find out more.
All right. Awesome. All right. I'll leave you two on the stage now. Thank you so much.
Thank you.